problems on Warshall's algorithm. So before going to Warshall's algorithm, we need to know what is meant by closure of relations. So the closure of a relation is nothing but the smallest relation that contains the given one which satisfies some certain properties. We are having three types of closure of relations. First one, reflexive closure. So the reflexive closure of a given relation is nothing but the smallest relation R dash that contains R, and it should be a reflexive one. So the straight formula is R dash, it can be written as R union delta. Delta is nothing but the set of all self-reflected elements. So if I take the set A as 1, 2, 3 and the relation R defined on A as 1, 1, 1, 2, 2, 3, 3, 1. So for this relation, the reflexive closure, we can write it as R dash is nothing but we are going to include all the self-reflected elements. Already it is given that 1, 1 is there. So 1, 1 it is already there. So we can write all the elements in R first. 2, 3, 3, 1. Now we are going to include the other self-related elements which is not in R. 1, 1 it is already there, but 2, 2 is not there. So we are going to include 2, 2, and then 3, 3 it is not there in R. We are going to just include 3, 3. So this R dash will be the smallest relation which contains R and it's reflexive. So this is called as the reflexive closure of the given relation. So next we are going to see about symmetric closure. Symmetric closure, the same definition applies. It is the smallest relation R dash that contains R and it should be a symmetric relation. So the formula is R dash can be written as R union R inverse. R inverse is nothing but just we are going to interchange the place of the ordered pairs. So for example, I am going to take the set A as 1, 2, 3 and the relation R as 1, 1, 1, 2, 2, 3. So now R dash we can write it as R union R inverse. So first I am going to write all the elements in R. Next I am going to include all the elements in R inverse. R inverse we are just going to interchange the places of the elements in R. So if I interchange 1 and 1 in the first element, I will get 1, 1. It is already there. Next one, we have to change the place of this 1, 2. If we change that, it will come as 2, 1. But 2, 1 is not there in R dash. So we are going to include 2, 1. So in the same way, if we change 2, 3, we will get 3, 2. But 3, 2 is not there in R dash. So we are going to include 3, 2. That's all. This R dash is called as symmetric closure of the given relation. Transitive closure. Transitive closure similar to previous two reflexive and symmetric closure. This is the smallest relation that contains the given one and is transitive. So the notation of transitive closure is either R plus or R infinity. The formula, we don't have any straight formula to find transitive closure. We can find transitive closure using matrix representation of the given relation. So first one, we are taking MR, then MR squared up to MR power N. So we are going to take R for all these matrices. So we will obtain MR plus. This is nothing but the transitive closure. And note that N represents the number of elements in the set A. Finding MR is easy, but if we have 5 by 5 matrix in MR, finding mr square and mr power 5 will be a tedious process. So, transitive closure can be obtained using Warshall's algorithm. This comes in hand to obtain the transitive closure. These are the steps in transitive closure, that is in Warshall's algorithm to find it. So we are going to start with the W naught matrix. W naught is nothing but the given matrix representation of the relation. To construct the further matrices W1, W2, W3, etc., these 5 steps are important. We have to write the positions of 1 in kth column. We are going to name it as J. Next one, we have to write the positions of 1 in kth row. We have to name it as I. Then we have to write the ordered pairs J, I. Note that first entry should be column entry, second entry should be row entry. We are going to retain 1 from the previous matrix Wk minus 1, and then additionally we have to put 1 in the jith position and remaining places as 0. We are going to repeat the same procedure till Wn, and then from the Wn matrix we can obtain the transitive closure. Let us see the first problem. Calculate the transitive closure of R equal to 1, 2, 2, 3, 3, 4 on the set A equal to 1, 2, 3, 4. So clearly the number of elements in the set A, it is 4. So now let us construct the MR matrix. MR matrix is nothing but here the entries will be 1, 2, 3, 4, and here it is 1, 2, 3, 4. So 1, 1 entry is not there, that is 1 is not related to 1. So we are going to put 0. 1, 2 entry is there, 1, 3 it is not there, 1, 4 entry is not there in R. Similarly 2, 1 it is not there in R. So we are going to put 0. 2, 2 entry is not there. So we have to put 0. 2, 3 entry it is there. So we have to put 1. And 2, 4 entry it is not there. So it will be 0. 3, 1 we are going to put 0. 3, 2 it is 0. 3, 3 entry it is not there. So 0. And 3, 4 we are going to put 1. 4, 1 it is 0, 4, 2 is 0, 4, 3 is 0, and 4, 4 is 0. So this is the MR matrix representation of the given relation. We are going to take this as our initial matrix W naught. Next one, we have to find further matrices Wk. So let us take k equal to 1. So Wk minus 1 will be W naught matrix. In W naught we have to see the first column. So let us take the first column. So see this first column, and we have to mention the places where we are having 1. So in first column there is no place with 1. So here there is no place. And similarly in first row we have to see it. So for first row, see the first row, at second place we are having 1. So the position is second one. Since there is no entry in the column place, ordered pairs also it is not possible. So W1, to write W1, remember that we have to retain 1 from the previous matrix. So in W0 we are having 1 in these 3 places. So at the same place we have to put 1, all the places. So additionally there is no ordered pair to put 1. So next one we are going to fill all other places with 0. Next one, we are coming for second step, that is k equal to 2. Now we have to see the kth column in Wk minus 1, that is second column in W1 matrix. So let us see the second column and see that at first place we are having 1. So here it will be 1. And we have to see the second row. Second row, we can see that at third place we are having 1. So it is 3. Now if we put ordered pair, we'll get 1 comma 3. First entry should be column, second entry should be row. Now for writing W2 matrix, first we have to put all the ones from the previous matrix. So it is 1, 1 and 1. Then we have to fill 1 in this place, ordered pair 1 comma 3. So this one will be 1 comma 3. We are going to put 1. All other places will be replaced with 0. 0, 0, 0 here, and fourth row it will be 0. Next one, we are taking k equal to 3. K equal to 3, we have to see third column in W2 matrix. So see the third column, this is our third column. Clearly first two places has 1. So here it will be 1 comma 2. And next we have to see the third row. In third row at fourth place we are having 1. So next it will be 4. Combining these two, we have to write the ordered pair. So it will be 1 comma 4 column comma row, and then it is 2 comma 4. Now writing W3 matrix, first we have to retain all the ones from the previous matrix. So it is 1 1 1, and here at 3 comma 4 place it is 1. Additionally, we have to put 1 in these ordered pairs. So it is 1 comma 4 place will be filled with 1, 2 comma 4 place will be filled with 1. We have to put 0 in the remaining places. 0 0, and last row will be entirely 0. Next step, we are going to take k equal to 4. We have to see fourth column in W3 matrix. So fourth column will be this one, fourth column. So clearly in fourth column, at the places 1, 2, 3, we are having 1. So here it will be 1, 2, 3. And then we have to see fourth row. This is our fourth row, and there is no ones in the fourth row. So at row place, no entry is there, and it is not possible to write the ordered pair also. So W4, this is equal to, we have to retain all the ones from the previous matrix. So it will be 1 1 1. Next one, there is no additional place to put 1, so we are going to replace all other entries with 0. Since number of entries in the given matrix is 4, we are going to finish with W4 matrix. Now we can write the R plus, that is transitive closure, as we know that these places 1 2 3 4 and row column places are 1 2 3 4. Correspondingly, we have to write all the entries where we are having 1. So in first row we are having 1 at 1 comma 2, 1 comma 3, 1 comma 4, and second we are having at 2 comma 3, 2 comma 4, and third we are having 1 at 3 comma 4. So this is the required transitive closure. So Warshall's algorithm is used to find transitive closure.